Welcome back, student. So now we are going to check out different thing in this lesson. Now we are going to end this topic. So dear students, be okay, comfortable with this. So here representation of half cell we have seen. Now we are also going to check out the representation of some different thing, and that will be very interesting. Okay, so dear students, come on, let's study the representation of thing. See here, we are provided one equation. Okay, this equation, aluminium is going to convert into aluminium 3 and gold plus 3 is convert to gold. So you can see that one is oxidized out and is reduced out. So now what is oxidized out and what is reduced out, that we have to see. And after that we are going to represent this cell. So this cell can be represented in this pattern. Okay, so I am showing that in which pattern this cell is to be represented. See, this cell can be represented in this formation: aluminium to aluminium plus 3, aluminium to aluminium plus 3 with its concentration. It is the oxidized part, that's why it is taken as a anode. Therefore it is taken as a anode. Gold is converted into gold. Okay, so iron converted into iron, and that is the reduction part taken as a cathode. So this is the simple. Okay, but now this is the most important point of the lesson, and that is, see, potassium when react with any acid, H plus means acid, and then potassium is converted to ion and hydrogen gas is liberated. We know that. Okay, now here if it is written in the form of the electrochemical cell, then potassium is converted into potassium ion. See, potassium is converted into potassium ion. You can see that. Okay, here. Okay, an ion of hydrogen is converted into hydrogen gas, and that is written in this pattern. See the pattern: 2k by 2k plus 1, 2h plus h2. Oh, here one more thing is added: platinum. Why platinum is added here is the question. And dear student, you can understand why platinum is added. Because when we were talking about the half cell, at that time we have seen that the platinum wire is to be joined with the other thing, and that is our knowledge. And that's why we can say that key here platinum should be. So anytime when hydrogen is taken, its half cell can be written in this pattern always. H should be there, then H2, then platinum. Hydrogen with atmosphere and H plus ion with its concentration. Here it is taken as a cathode, but here it is taken as a anode. And see how in term of anode it is taken, that you can see. Check out that for a while. See how it is taken as a cathode at that time, what is happening. So hope that you understand the representation of hydrogen half cell as an anode and as a cathode. Okay, so up to this, this is the important topic. Now the application of this calculation, that is the Nernst equation, that we are going to study. And dear student, the applications are more interesting and more effective. So dear students, that we are going to study the application of the Nernst equation. Dear students, as here we have 2H plus ion. And now what is 2H plus ion? It is nothing but the acid. And if acid is there, then we can find out it's what? You understand? What you can find out? We can find out pH. So now we are going to perform the sum on the base of the find pH. Okay, sum on the base of to find pH. So come on, let's do the sum on the base of pH. So first sum is, I will give you like this. This is the first sum. Find the value of okay, now you can read it properly. Find the value of pH if given cell has the potential 3.2 volt and the given cell is in this pattern. It is given, okay, which is the pattern? See this pattern given. Here the concentration of H plus is not given. If we have a concentration of H plus, then we can find directly. So by using what? By using this calculation, we can find the X value as we have done in previous lesson. So step number 1, you know, okay, what is the step number 1? So in step number 1, in solution, step number 1 we always do to find out the E degree cell. And dear students, for E degree cell we have this equation here. Now anode is potassium and cathode is hydrogen. Hydrogen half cell always has 0 volt, and here the voltage of potassium is given minus 2.93, that is equals to minus minus plus, and that is the total voltage is equals to 2.93 volt for this cell. Okay, so hope that you understand. The answer is here 2.93 volt. Okay, now afterwards you know that we have to use the Nernst equation. So I have putting here Nernst equation, and now we are finding the terminology in the Nernst equation. And fatafat you tell me which are the terminology here. E cell we have given here 3.02 is the E cell. E degree cell we have find out 2.93 is the E cell. Number of electron transfer, potassium 1, hydrogen 1. Anode concentration is given 0.05 and cathode concentration is given, that is X. So here we can find out first X. So to find out X, I am putting again the Nernst equation, okay, and that Nernst equation value you have to replace. ચલો કોણ replace કરાવશે આ Nernst equation માં value? E degree cell ની value કેટલી છે જુઓ. E degree cell ની value E cell ની rather 3.02, તો આપણે મૂકીશું 3.02. E degree cell ની value કેટલી છે? 2.93, તો આપી દઈએ અહીંયા 2.93. n કેટલા છે? 1, તો આપણે અહીંયા કેટલા લખી દઈશું? 1 લખી દઈએ. n ની જગ્યા પર 1. એનોડ કેટલા છે? એનોડ ની વેલ્યુ છે 0.04 and cathode is given X, તો અહીંયા લખી દઈએ X. Okay, now we want to find by using this X. So how to find X? ચલો તો બધાય પહેલું તો as usual હવે તમે જાણો જ છો કે ભાઈ this 2.93 આ બાજુ આવીને માઇનસ થઈ જશે. ઓકે, so we have to first do minus there. So I am doing that, implies that મૂકી દઈએ એટલે વચ્ચે તમને કોઈ તકલીફ નહીં પડે. ઓકે, so implies that 3.02 minus 2.98 અને અહીંયા માઇનસ ઇઝ ઇક્વલ્સ ટુ માઇનસ એમની એમ જ સાઇન રહેશે અને બાકીનું બધું એમ જ રહેશે, બટ 0.0592 અને પેલી બાજુ log of